Hello everyone, so today we're going to look at the index laws in a bit closer detail. We're going to go through the first three index laws in the first half of the lesson, and then we're going to introduce the fourth index law and how do we apply that. Okay, so quick recap, the first index law, if we think about it, is a to the power of m multiplied by a to the power of n. And then when we do the calculation, we just need to combine the indices by adding them together. Now, if we think about how do we use them, say suppose we have 8 to the power of 2 times 8 to the power of 3. Now notice these two indices have the same base, and therefore we can just say it is equal to 8 to the power of 2 plus 3. Because the multiply, according to the first rule, will transfer to plus. So therefore we get 8 to the power of 5. And that is our final answer. Okay. Now, why is this one true? Now, before we move on to proving it, we'll just look at some basic. First of all, the indice notion a to the power of m means we multiply this number a, the base number, by m times. Okay, so if we have the indices which says a to the power of m, that means a times a times a, and we multiply it by m times. Okay, same way, it's a to the power of n will be a times a times a, and we multiply it by n times. Now, if we look at the whole thing, we'll notice we multiply the same number a by m times, then we multiply it by n times. So in total, we would have m plus n times, and therefore it is equal to a to the power of m plus n. Okay, now there's a big practice question when we look at the complexity of this question. When we have the number and the prenumerals like x and y, we need to treat them separately. That means number goes to number, x goes to x, y goes to y. So the number goes to number, so that's 7. Okay, and the x goes to x, so x we have the power of 3 and power of 4. And if we multiply them, we have 3 plus 4. Right, and the y goes to y. Right, we got y to the power of 3, then we got y to the power of 2. So we just need to add them together. So in total, we would have 7 times x to the power of 7 times y to the power of 5. Okay, so this is a bit notion. When we say, for example, x cubed then y, if there's nothing in between x, y, or the number, that generally suggests multiplying it. So for example, 7x actually means 7 times x. Now, the reason why we don't write this multiply is because it looks very similar to x and could easily cause the confusion. So the traditional notion, we just don't use this one and we try to use with 7x. Okay, now let's look at the second index law. The second index law is very similar to the first one. The only change is instead of multiplying, we are dividing on the left hand side, and instead of adding, we are subtracting on the right hand side. Okay, now still we're doing the operation based on the same base number, and we're just calculating based on the indices. Now, for example, let's look at this question. So when we have 5 in the power of 6, divide by 5 in the power of 3. Notice it has the same base of 5, so we write the base number 5. Now it has the indices 6 and then divide by 3, so we change this divide to subtract. So 6 take away 3. So in that sense, we have 5 in the power of 3. So it's actually down here. Now, if you want to expand this one step further, you get 125. Okay, so now this is optional. You don't have to go through this bit, but this is explaining to you why this is so important to do the power indices because we can represent the same information with less number. Okay, it'll make a lot of difference when we go through a very big number. We may use a very small number on the indices, but we can eventually get a crazily large number as the output. Now, why is this the case? Why is this true? So how do we prove that? Okay, so that basically means if we have a to the power of n, remember we just say a times a lot of a, and then we say there are m times. We just multiply the same number a by n times. Now divide is the same as drawing a fraction, okay? A times all the way to the a, and this time we have, let's just say n times. Now, one important feature about division or the fraction is that we can simplify it by crossing the same a's. Okay, so we can keep going. So if we have another a, then we can cross that one as well. So if we keep crossing this all the way at the bottom, that means we crossed n times of the a's. So that means on the top we have m take away n times. Okay, so for example, if we have like 10 at the top and 2 at the bottom, we would have the difference, which is 2. Oh, sorry, the 8. Okay, so in another word, this would equal to a to the power of m take away n. Alright, so this is the second law of the index. Now, when we look at a more complex issue, just remember number goes to number, x goes to x, y goes to y, so on and so forth. So the number goes to number. 16 and 12, we can sort of simplify it by dividing the common factor 4 in this case. So the top one divided by 4 will give us 4. Bottom one divided by 4 will give us 3. Okay. Now then we have the x and y. So we can just say x. Now this time we have x to the power of 8 divided by x to the power of 2. So we just, instead of writing divide, we write minus on the power indices. And then same for the y. Okay, we have y to the power of 6 divided by y to the power of 3. Instead of divide, we write minus. So in this case, we will get 4 over 3 times x to the power of 6 and then 1 to the power of 3. And that is the solution to this question. Now notice that x and y are different things, so we cannot combine these two. So do the operation for x and do the operation for y and treat them separately. Okay. So we'll move on to the third index law. The third index law is a bit interesting. It's about the power indice on a power indice. So this will read as a to the power of n to the power of n. Now, if we write it by hand, we can also write it as a to the power of m to the power of n. So it will look a little bit like this. Now, but when we are doing the calculation, we are actually doing that by a to the power of m times n. Okay, so we see how it works. So for example, if we have 3 to the power of 2 to the power of 4. Now notice when we power indices, then we have 2 times 4. So instead of the bracket, we replace that by a multiply. So in this case, we have 3 to the power of 8. And that's it. That's the conclusion. That means we multiply this number 3 by 8 times. So why is this true? Okay, so how do we know that this is true? Now, if we just represent the whole thing, a to the power of n to the power of n, that means we multiply this number by n times. So that means a to the power of n times a to the power of n times a to the power of n. We just keep times it by itself. And we need to make sure that we multiply it by n times. Okay? Now, also, we can use the first index law. Okay, if we use the first index law, remember when we are multiplying two power indices, we are just basically using the addition. So add, and add m. And we add that by n times. So if we add the value of m by n times, it's a bit tricky in pronunciation. We just say, therefore, we have m times n, or you can put multiply here if you want. Okay. Now the practice question. Now this one goes a bit harder. It's actually applying the second and the third index law together. We'll have a look. So now below the fraction we have b to the power 4. We just keep it. On top, on the numerator, we have b to the power of 2 to the power of 5. So instead of say to the power of, I can replace that by a multiply. So multiply it by 5. So in this way, we get b to the power of 10 divided by b to the power of 4. Okay, so if we do that, we would get b to the power of 10 take away 4. So remember, divide becomes take away when we're doing the power indices. So that will give us b to the power of 6. And this is the final solution. Okay, so if we take a summary snapshot of the first three index laws, okay, these three are, well, very popular and very common in use. The way to memorize that is that for each basic calculation, we try to change it to the calculation on the index. So for example, if the basic calculation is multiplied, on the index level, the calculation becomes plus. And if the basic calculation is divide, on the index level, it becomes minus. In a sense, it's actually quite consistent because multiplying, adding are making things bigger, and dividing and subtracting are making things smaller. Okay, and the last one, if we're doing the power indices, then we are multiplying it. Okay, now let's go on to the next page. Today you're going to learn one new thing, which is the fourth index law. It's actually very easy to remember. That is, anything to the power of 0 will give us 1. And there will be only one exception. We'll need to make sure a is not 0. Now, this is a very complicated definition. So we'll need to make sure any non-zero number to the power of 0 will give us 1. So for example, if we have 3 to the power of 0, now remember everything in the power of 0 will give us 1. So 3 is not a 0, so we have that equal to just 1. End of story. Okay, so how do we prove that? Remember when we're doing the second index law, we're just saying if we have a power indice divided by another power indice, we just use a to the power of m take away n. Right? So if we want to prove that, we can say a to the power of 0. It is equivalent to say a to the power of, let's just say 2, take away 2, because that will give us 0 anyways. Okay, so what it means is a times a divided by a times a. Now we can just cross all the things, and that will give us just 1. Okay, so the number divided by itself will give us 1. Last bit we look at a practice question. It's also one of questions. So if we look at that, a to the power of 0 is giving us 1. So we have 1 here, plus 1 here, and plus 1 here, which will give us just 3. End of story.